Hello and welcome to another video. In this one we're talking about two things that are pretty easily confused, and that's because they have basically the same name, and that is not implemented and not implemented error. And I'm going to show you where you would use either of these two things in Python. So let's jump into it. Okay, so the first that I'm going to explain is not implemented error, because I think it's the easiest one to explain. Not implemented takes a little bit more work to talk about. And the idea behind not implemented error is it's a nice placeholder exception type to denote that a functionality has not been done yet. So I often use this when I'm stubbing out a module and, incrementally doing some test-driven development to write out the actual code. And so I might do something like, def sum API and, raise not implemented error, not yet complete, or something like this. Or maybe I'll have some code that does a bunch of different cases, and like there's some case that I am intentionally not handling yet. So like, if, case one, do thing, elif, case two, do other thing, else raise not implemented error, unexpectedly not implemented. Often I'll kind of interchange not implemented error and assertion error in this sort of unexpected not implemented case. I think assertion error is actually a better way to communicate this, but not implemented error can do the same as well, since both of them are pretty unlikely to be caught. But that's not implemented error, so it's kind of like a placeholder place to say, I'm intentionally not done with this yet. In fact, I usually exclude these sort of lines from coverage because I find that, testing that you haven't implemented something is a little bit weird, a little bit of a waste of time. But yeah, that's not implemented error. The other one, which is not implemented, has to do with comparisons in Python. So I'm going to actually write a few little classes here, and we're going to use those to do some comparison code. When I mean comparison, I mean like less than, greater than, does not equal to, etc. So I'm going to make two classes, def init self x, none self.x equals x. We'll give this thing a repr so that it's easy to see what's going on. Turn f string type self.name and self.x as the value in that repr. We're actually going to make two classes. Note here that C is going to have an attribute X, and I'm going to make a class D that has an attribute Y, just to make these slightly different from each other, to kind of demonstrate my point here. Okay, so let's start with just blank classes. These don't have any comparison operators implemented at all. If we run this, you can see if we do C1, we get C1. If we do D2, we get D2. And what we're going to concern ourselves with today is the comparison of these two. So I'm going to say, is C1 less than D2? And since I haven't done any implementation of comparison operators, we're of course going to get a type error that says that, there's no supported comparison between these two. So let's start implementing one of these operators. I'm going to start by implementing the less than operator, def lt self other. And a common mistake when implementing comparison operators is to use the type of the class that you're using. So let's say, and I quoted this, actually we can just do from future import annotations. One common mistake when implementing the comparison operators is to assume that the other value that's passed in here is the same type. So this is actually an incorrect annotation here, but let's assume that I didn't know how to do this properly, and so I'm going to write code that just compares against this C here. So we're just going to return self.x is less than other.x. And if we run this, you'll see that if we use C's, the comparison works, and if we do C0, you'll see that we get false. So that works all fine and dandy, but if we start comparing disparate types now, you'll see that we actually get a trace back here, and this is because this less than operator implementation is done incorrectly. So in order to do this correctly, we must change this to object, and we must handle all types inside this less than operator. And this is where not implemented comes into play. So there are infinite types in Python, and so you can really only know how to handle a specific subclass of those inside your less than operator. And for the cases where you don't know how to handle it properly, you should return the not implemented singleton. And so in this case, we know that this case happens if we are a C object. So we can say if is instance other C, then we return this here. But if we don't know about the type, we should return not implemented. Implemented. So instead of crashing with an attribute error, what it should do instead is fall back to this same sort of type error that we had up here. So again, do C1 less than C2. You can see that these work fine, but as soon as we do C1 less than D2, you'll see that there's not a supported, less than operator for those. That said, Python uses this signal here, this not implemented signal, to try the other, the flip side of this operation. So we can check, like, if C doesn't know about D, maybe D knows about C, and C can answer this question. So some types can have more information enough to do these sorts of comparisons here. So let's say that we went to D and we went to implement our own less than here. And again, we're going to use other object and return a Boolean. But maybe D has specialized knowledge of C, and so it knows that it can compare against it. Oops. Right. So if is instance other C, we know here that because this is a C object, we can compare our y against C's x. So return self.y less than other.x. Elif is instance other D. We know that if it's a D, we can just do self.y less than other.y. And again, if we don't know any of the types that's happening here, so maybe it's some other value that's passed in, we can just return not implemented. Now this is actually insufficient to implement this problem here. So if I did C1 less than D2, you'll see that we get a type error here. And this is because we haven't actually, the flip side of this, the opposite of this is actually using the greater than operator. And so it has to know how to flip to greater than, and we've only implemented the less than operators. Now, fortunately, there's a cool thing that you can do in Python where, implementing these operators is kind of a pain in the butt. There is this decorator from the functools module. So if we import functools, there is a functools.totalOrdering operator here. And what this does is it gives us operator definitions for all of the other operators, as long as we just implement less than. I think you might also need equality. We'll try it and see what happens. But the reason that you can implement all the other ones from less than is equality is not less than and not less than. So if you flipped less than around twice, you would say, it's either one of these. So if both of those are false, then it must be the same value. I'll give you an example. So like 1, x equals 1 and y equals 1. Equality of these can be written as, not x less than y and not y less than x. Because this would be true if it was less than, and this would be true if that one's less than. So you can see because they are equal, this expression is true. So you can rewrite the equality operator using this, and from that you can write less than or equal to, and because you can write less than or equal to, you can write greater than, and because you can write greater than and equal to, you can write greater than and equal to. So you can derive all of the other operators just from less than, which is kind of nifty. And again, if we change this to 2, you can see that this equality check is now false. And so that's what total ordering does under the hood. They might they might actually require equality for other reasons, but I think this works. I mean, it succeeded so far. So now you can see that I can write C1 less than D2, and that works out fine because this less than operator knows how to implement, comparison against this other type. But anyway, that's the difference between not implemented error and not implemented. I also gave you a nice taste of functools.totalOrdering and this little Boolean less than trick here, which when I first learned about this in C++, actually, I was very impressed. This was a really cool thing about programming to me. But anyway, hopefully this was interesting. If there are additional things you would like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.